8th grade, Unit 5, Lesson 9, Linear Models. Problem number 1. On the first day after the new moon, 2% of the moon's surface is illuminated. On the second day, 6% is illuminated. A. Based on this information, predict the day on which the moon's surface is 50% illuminated and 100% illuminated. I'll make a chart and label the first day 2% illuminated. And like they said, the second day was 6% illuminated. So I added 4. So each day we can add 4 until finally we reach 50%. On day 13, we reach 50%. Let's keep going. Right between day 25 and 26, we reach 100%. So on day 13, the illumination will reach 50%, and right about day 26, the illumination will reach 100%. B. The moon's surface is 100% illuminated on day 14. Does this agree with the prediction you made? No, it doesn't agree. The prediction I made, it was 100% illuminated around day 26. C. Is the percentage illumination of the moon's surface a linear function of the day? I put the points on a graph representing 1 day with 2% illumination, 2 days with 6% illumination, and 14 days with 100% illumination. And that would not form a straight line, which means it's not a linear function. Problem number 2. In science class, Jada uses a graduated cylinder with water in it to measure the volume of some marbles. After dropping in 4 marbles, so they are all underwater, the water in the cylinder is at a height of 10 milliliters. After dropping in 6 marbles, so they are all underwater, the water in the cylinder is at a height of 11 milliliters. A. What is the volume of 1 marble? 2 marbles added 1 milliliter to the height of the water. That means that adding 1 marble adds 0.5 milliliters to the height of the water. So the volume for 1 marble is 0.5 milliliters. B. How much water was in the cylinder before any marbles were dropped in? The volume of each marble is 0.5 milliliters. 0.5 milliliters times 6 marbles equals 3 milliliters. 11 milliliters minus those 3 milliliters equals the 8 milliliters that was originally in the graduated cylinder. C. What should be the height of the water after 13 marbles are dropped in? 5 milliliters times 13 marbles equals 6.5 milliliters, and add that to the original 8 milliliters that were in the graduated cylinder, and you get a total of 14.5 milliliters. After adding 13 marbles, the height of the water should be 14.5 milliliters. D. Is the volume of the water a linear relationship with the number of marbles dropped in the graduated cylinder? If so, what does the slope of the line mean? If not, explain your reasoning. Yes, it's linear, and the slope of the line means the volume per marble. Each time you drop 1 marble in the cylinder, the water level rises 0.5 milliliters, and the number of marbles increase by 1. Problem number 3, from 8th grade, Unit 4, Lesson 5. Solve each of these equations. Explain or show your reasoning. We can divide both sides of the equal sign by 2. Subtract 2 from both sides. Subtract 1x from both sides. Divide both sides by 2. 1x equals 6, or x equals 6. Add 3y to both sides of the equal sign. Subtract 13 from both sides of the equal sign. Divide both sides of the equal sign by 8. Y equals -7. We can use the distributive property 4 times 2a plus 4 times 2 and 8 times 2 minus 8 times 3a. Subtract 8 from both sides of the equal sign. Add 24a to both sides of the equal sign. Divide both sides by 32. 8 over 32 is equivalent to 1/4, so a equals 1/4. Problem number 4. For a certain city, the high temperatures in degrees Celsius are plotted against the number of days after the new year. Based on this information, is the high temperature in this city a linear function of the number of days after the new year? The points are plotted on this graph. The rise is 4 and the run is 2. From this point to the point on the top, the rise is 14 and the run is 7. 7 over 14 is a slope of 2, just like 4 over 2 is a slope of 2. And if you were to draw a line straight through these points, you would have a straight line. The straight line proves that it is a linear function. However, to use a linear model for this situation doesn't really make sense because after a couple months, the temperatures would be so hot that you couldn't survive. Problem number 5. From 8th grade, Unit 4, Lesson 15. The school designed their vegetable garden to have a perimeter of 32 feet, with the length measuring 2 feet more than twice the width. A. Using L to represent the length of the garden and W to represent its width, write and solve a system of equations that describes this situation. Here's a garden box with the length and the width, and you notice that there's 2 lengths and 2 widths. The perimeter is equal to length plus width plus width. And that's the same thing as 2L plus 2W. And adding them all together will give you the perimeter, which is 32 feet. The length of this particular garden box measures 2 feet more than twice the width. So we can write that as L equals 2 plus 2W. So we know that the length equals 2 plus 2W. That means that we can substitute this L with 2 plus 2W. So we can rewrite this equation as 2 times 2 plus 2W plus 2W equals 32. Next, use the distributive property. 2 times 2 is 4 plus 2 times 2W. Next, we can collect like terms. 4W plus 2W equals 6W. Subtract 4 from both sides of the equal sign. Divide both sides by 6. Now we know that 1W equals 28 over 6, which is equivalent to 4 and 4/6 and can be simplified to 4 and 2/3. W equals 4 and 2/3. Now we can substitute the W with 4 and 2/3, or 28 over 6. Now we can rewrite the equation as L equals 2 plus 2 times 28 over 6, which means L equals 2 plus 2 times 28 over 6. And 2 times 28 over 6 is 28/3. So L equals 2 plus 28/3. 2 is equivalent to 6/3. So we can add 6/3 to 28/3. That gives us 34/3. So we know that L equals 34/3, which can be written as 11 1/3. Now we know that the width of the garden box is 4 2/3 feet and the length of the garden box is 11 1/3 feet. Help me disrupt YouTube's algorithm by liking this video, commenting on this video, sharing this video, and subscribing to my channel. Thanks. I appreciate it.